Let's learn basic proportionality theorem, which is also known as the Thale's theorem, which is abbreviated as B.P.T. Prove that if a line parallel to a side of a triangle intersect remaining sides in two distinct points, then the line divides those sides in the same ratio. Let's give solution of this theorem. Okay. As per the statement, we need a triangle. Let's consider triangle ABC. Okay. Now let's consider such a line parallel to a side of a triangle intersecting remaining two sides in two distinct points. Let that line be line L. Line L parallel to side BC intersecting AB and AC in points P and Q. Okay. Let's mention these things in given. In triangle ABC, line L parallel side BC. Line L intersect side AB and side AC in points P and Q respectively. Okay. If a line parallel to a side of a triangle intersect remaining sides in two distinct points, this is the antecedent part which we have mentioned in given. Now consequent part, the line divides those sides in the same ratio, and the consequent part we use to prove. Here you may note, line L divides side AB in two parts, AP and PB. Similarly, side AC in two parts, AQ and QC. As per this statement, ratio of AP with PB equals AQ with QC. That's why to prove will be AP upon PB equals AQ upon QC. Now information is not sufficient. That's why we are going to write here construction. Draw seg PC and seg BQ. Okay, let's draw seg PC and seg BQ. Okay, as we are interested with AP upon PB, let's consider a pair of triangles APQ and triangle BPQ. Okay, in the case of triangle APQ and triangle BPQ, if AP and PB will be their bases, their corresponding height we are going to draw through vertex Q. And if we draw height through Q on AP, that height, let us call it as QE. Okay. In triangle APQ, AP is the height and AP is the base and QE is the height. In triangle BPQ, PB is the base and QE is the height. Means these are the triangles having same height. And we know that ratio of areas of two triangles having equal heights equals ratio of their corresponding bases. Okay. Now let's mention these things in a proof. From figure, area of a triangle APQ and upon area of triangle BPQ. Area of triangle APQ upon area of triangle BPQ equals AP upon PB. AP upon PB. Equation first. Since triangles having equal heights, Okay, we need not to write name of their height. Okay, now to get the ratio AQ upon QC, let's consider a pair of triangle APQ and triangle CPQ. AQ is a base, QC is a base. Okay, for these bases, let's draw seg P up perpendicular to AQ. Now AQ is a base, P up is a height in triangle APQ. Similarly, in a triangle CPQ, QC is a base and P up is a height. Means it is a pair of triangles having equal height. And we know that ratio of areas of two triangles having equal heights equals a ratio of their corresponding bases. That's why here we can write area of triangle APQ upon area of triangle CPQ equals AQ upon QC. Equation second. Since triangles having equal heights. Okay. Now, let's consider a pair of triangle BPQ and triangle CPQ. Okay. This pair lies between two parallel lines with common base PQ. And in case of triangle BPQ, if PQ is a base, then we need to draw perpendicular through this B. Okay, on line PQ. Similarly, in a case of triangle CPQ, if PQ is a base, then we need to draw perpendicular through vertex C on line PQ. Okay, let the put of perpendicular through B on line PQ is a G and let it be H. Here you may note BG and CH, these are distances between two parallel lines, and we know that distance between two parallel lines is always constant, and therefore these are the triangles having equal bases and equal heights, and we know that areas of two triangles having equal bases and equal heights are equal. We are going to mention here. Now, triangle BPQ and triangle CPQ have common base PQ and they lie between two parallel lines that is PQ is parallel BC, and therefore triangle BPQ and triangle CPQ have equal bases and equal heights, and therefore area of triangle BPQ equals area of triangle CPQ. Let's call it our equation third, and therefore from 1, 2 and 3 area of triangle APQ upon area of triangle BPQ equals area of triangle APQ upon area of triangle CPQ. Therefore, AP upon PB equals AQ upon QC. Hence the proof.